Imagine a software engineer at Coinbase on a Monday morning.
Right.
They have this brilliant idea for a new feature. Now, 2 years ago, that idea sat in a really sluggish pipeline.
Oh, absolutely. The endless Jira ticket updates.
Exactly. It required all these planning meetings. It took 8 full days just to become a pull request.
Yeah.
Today, that exact same process takes under 30 minutes.
It is wild.
It really is. It is staggering to think about. But here's where it gets highly interesting. The secret isn't just the sheer power of the AI itself.
No, not at all.
It actually requires the exact legacy engineering skills we thought were dead.
Right. Skills we assumed AI was going to completely replace.
Welcome to the deep dive. Today, our mission is exploring autonomous coding agents. We are looking at tools like Claude Code, Codex, and Cursor, and we will see how they actually make traditional software engineering skills more valuable than ever before.
The shift is truly incredible to witness, honestly. We are rapidly moving away from humans just manually typing out code.
Right.
Now, humans are building these massive systems that manage the AI.
Which is a whole different ballgame.
Exactly.
Yeah.
So we will look at real enterprise setups today from OpenAI and Stripe. We will break down exactly how to automate away recurring AI mistakes.
Yeah.
And ultimately, we're going to completely redefine what a senior engineer actually does.
Okay, let's unpack this core paradox first.
Yeah.
Because before these coding agents arrived, development was, well, very isolated.
It's isolated, yeah.
An environment supported one single human developer. You wrote your code, you ran your own tests locally.
It was a very simple one-to-one relationship.
Yeah.
Your local machine was set up perfectly for your specific kind of idiosyncratic habits.
Right.
But now, that exact same setup has to guide many autonomous agents, and they are all working simultaneously across an entire massive code base.
Which introduces absolute chaos if you lack strict boundaries.
Whoa, total chaos.
Before agents, one bad commit maybe ruined your afternoon. Now, 10 agents running parallel tasks could theoretically corrupt an entire architecture in seconds.
Exactly. And this is why traditional system rules are absolutely foundational now. They are literally the only way to allow AI to function safely at scale.
This brings us to the OpenAI Codex case study.
Right?
They built a complex product utilizing Codex internally, but they didn't just unleash the AI and hope for the best.
No, they created a tightly controlled environment first. It was highly rigid. What is fascinating here is how they enforced architectural rules mechanically.
They didn't just write a polite prompt asking the AI to behave nicely.
No, polite prompts don't scale. They built custom linters.
And for those unfamiliar, linters are tools that scan code to automatically block formatting or logic errors.
Yes. Think of them as automated tripwires. They are hidden right there in the deployment pipeline.
So they just catch the bad code immediately.
Exactly. They instantly detect and block it before it merges into the main branch.
They hard-coded their architectural boundaries directly into the working environment. And they paired these linters with incredibly robust CI workflows. And CI workflows are automated systems that test and build code before merging changes.
They checked deep dependency rules automatically on every single agent commit. It was rigorous.
Wow.
They checked for structured logging protocols. They strictly enforced variable naming conventions. They even had hard file size limits.
So how does this feedback loop actually work under the hood? I'm trying to visualize the mechanical interaction here.
Sure.
If the AI breaks a rule, how does it know why it failed? Does a human engineer have to step in and translate the error code?
That is the genius of their automated setup. No human engineer ever steps in to explain the failure.
Really?
Never. When Codex broke an architectural rule, the linter didn't just flash red and stop.
Okay.
The lint message actively rejected the bad code, sure, but it also did something else.
It explained the exact structural problem to the agent.
Yes. It appended detailed fixing instructions directly back into the agent's context window.
So the AI learned how to fix it immediately from the system itself. I picture this dynamic kind of like bowling with bumper lanes.
Oh, I like that.
The AI is the bowling ball rolling down the lane. It desperately wants to knock down the pins and build the feature.
Right, it has a goal.
But the lint rules and CI tests are the physical bumpers. They keep the ball completely out of the gutter. We do not have to watch every single roll manually.
Because the bumpers handle all the micromanagement for us.
Yes.
And once those physical bumpers are locked into the code base, they reliably guide every future code change made by any agent.
So no engineer has to endlessly repeat instructions in every single prompt.
Exactly. It lets the entire team move incredibly fast.
Because the underlying architecture stays perfectly consistent despite the massive volume of generated code?
Yep. Every coding agent gets that instantaneous, perfectly accurate feedback. You get exponentially more code without checking every tiny logic change
Yeah.
manually.
And the overall software quality doesn't degrade over time.
Not at all.
I am struggling with the implications of the feedback loop here, though. Does this mean manual code review is basically dead?
That is a great question. It definitely shifts our daily focus away from the mundane stuff.
Okay.
We absolutely stop reviewing basic syntax errors or missing brackets. Instead, we review the underlying integrity of the system rules themselves. We audit the bumpers.
Got it. We review the system's guardrails, not just the raw code.
Yes, and that is a massive conceptual leap. You are managing the overarching system that directly manages the AI.
So we know these system rules are entirely non-negotiable now. They keep the autonomous agents from silently destroying the code base.
Right.
But OpenAI's approach works for a tightly controlled custom-built environment. What happens in the messy reality of the trenches?
Oh, it gets complicated.
Because I still wrestle with prompt drift myself.
We all do.
It is incredibly frustrating. The agent fixes a complex issue perfectly on Tuesday,
Yeah.
but then on Thursday, it completely forgets the broader context. It makes the exact same architectural mistake all over again.
You are definitely not alone in facing that specific friction. Boris Cherny, who created Claude Code, has a brilliant insight on this exact problem.
Oh, really?
He argues that manually fixing the same issue repeatedly is a dangerous trap.
Well, it wastes expensive computing tokens for one thing.
It does.
Yeah.
But worse, it severely risks future architectural misses.
Right.
Eventually, the human reviewer gets tired. You might miss that same hallucinated import on the 10th time it happens.
Humans get fatigued.
Exactly. So the overarching goal is to turn that temporary prompt solution into a permanent boundary.
We need to systematically automate the automator.
Bingo.
But how do we build these rules when the AI keeps repeating very specific errors? Let's break down the practical workflow from our sources.
Okay, imagine Claude imports a module from the wrong architecture layer. Let's say it grabs a database driver for a front-end component.
Which is a classic AI hallucination. It just grabs whatever looks plausible to save time.
It happens constantly. Now, your first instinct is usually just to type, hey, fix this import path.
Right.
You have to resist that urge immediately. Do not just ask it to fix the raw code.
Because that doesn't solve the root issue.
Exactly. You have to force the agent to understand the underlying pattern. You give it a very specific, deliberate sequence of steps.
Okay.
Step 1. Ask it to show hard evidence of this repeating issue.
So you make the agent dig through the commit history and find the pattern itself.
Yes. Step 2. Ask it to explain the fundamental root cause. Why is it consistently misunderstanding this specific architectural boundary?
And step 3 is where the real magic happens, I assume. You ask it to proactively choose a long-term solution.
Like writing a new custom Lint rule or generating a new automated test.
Yes. And finally, step 4. You force the agent to build a solution and confirm it actually detects the problem.
It has to mathematically prove the new bumper works.
Let's ground this in a specific, concrete example from the source material to make it real.
It really highlights the power of this methodology, honestly.
So 2 front-end UI files completely bypass the back-end service layer. Yeah. They were querying the database directly. And the codebase's existing automated tests completely missed this severe violation.
They missed it because traditional tests usually only check the final user output.
Right. They just verify if the button turns blue when clicked.
Exactly.
Yeah.
They rarely check the hidden architectural path the data took to render that button.
So the engineering team used this exact prompt workflow we just talked about. Claude Code analyzed the critical gap in the testing suite. It realized why the UI was able to fetch data directly without triggering alarms.
And then it generated a highly reusable structural check. It added that new check directly into the CI workflow pipeline.
So the new test failed when the bad direct query code was present.
Yep.
And it passed successfully when the correct architecture was restored. It removed the manual work we would normally repeat through endless, exhausting prompts.
Every single automation you build like this permanently hard codes your team's specific standards. It's beautiful.
But here's where I get slightly skeptical about this entire process.
Wow.
Isn't asking an AI to write its own governing rules slightly risky?
Yeah.
It feels a bit like building a flimsy house of cards out of AI-generated Lint rules.
That is a very valid operational fear. which is precisely why this specific prompt workflow demands hard historical evidence.
Ah.
The AI cannot just invent a restrictive rule based on a momentary hallucination. It must prove the repeating issue exists in the actual code base history before proposing any structural change.
Makes sense. Require hard historical proof before changing the actual system rules.
Exactly. You never just let it guess at your architecture.
Yeah.
You make it prove the fundamental problem exists first.
But catching errors like that is still purely reactive, though. We are building the bumpers after the ball already went into the gutter.
Sure.
We need to shift our thinking to the proactive side now. How do we give these agents the hidden team knowledge up front?
The unspoken context.
Yes, the stuff that usually only lives inside a senior developer's head.
And that hidden context is absolutely everything. I mean, AI doesn't automatically know why your specific team chose a relational database over a document store.
Right.
It doesn't inherently know your bespoke historical naming conventions.
And when it lacks that crucial context, it just guesses.
It does.
It hallucinates a convention that looks plausible, but is fundamentally incompatible with your stack. It is kind of like stacking Lego blocks of data using the wrong size pieces.
That's a great way to put it. And this specific problem scales exponentially as your team grows.
I can imagine.
Stripe faced exactly this terrifying chaos when they evolved their workflow. They handed Cursor out to over 3,000 internal developers.
3,000 developers using AI agents simultaneously.
Yeah.
Think about the sheer volume of code being generated every hour. If every agent is blindly guessing at the internal rules, it would be absolute anarchy.
The merge conflicts alone would crash the entire system.
Wow.
So to proactively prevent this, Stripe utilized something called Cursor rules. This provided deep, bespoke code-based context right from the very start.
Let's unpack the actual mechanics of that system. How do cursor rules actually interface with the IDE's context window?
Good question.
Because it doesn't just force the AI to read the entire massive repository every time you type.
No. That would fry the context window immediately.
Right.
Under the hood, it injects only the rules relevant to the specific domain the developer is currently touching.
So a front-end developer automatically sees the front-end guardrails.
Exactly. And a back-end engineer automatically gets the database rules.
The AI already knows the intricate rules of the road before the developer even types their very first prompt.
They do not have to explain team conventions ever again.
You can structure this exact same proactive knowledge yourself, too. If you're using Claude Code, the mechanism is a file simply named claude.e.mdd.
Yep.
It sits right in the root directory of your project.
But the underlying strategy for writing this file is crucial. It must be brutally, ruthlessly concise.
2 sec silence.
It acts as a lightweight map pointing to deeper external documentation. It is not a giant, sprawling dump of every single project rule.
Okay, but say you have a massive, undocumented legacy project.
A nightmare scenario, sure.
How do you actually build this map without spending 3 agonizing weeks writing it manually?
There is a brilliant prompt strategy specifically for this scenario. You leverage the agent to explore and map its own environment.
Oh, that's smart.
You ask the AI to thoroughly study the existing code base.
So you have it trace the underlying architecture and the complex data flow.
Yeah.
You have it document your repeatable terminal commands and build workflows.
Then you ask it to draft short, punchy instructions for that clay.md file. It can even propose specialized deeper docs for highly complex functional areas.
But here is the critical catch in the workflow. You mandate a hard pause for human approval.
This is non-negotiable.
The AI is strictly forbidden from modifying any actual files during this discovery phase.
You review the drafted map first. You verify it accurately reflects the unspoken ghost in the machine of your team's actual culture.
And only then do you let it commit the documentation.
Exactly.
I have to challenge this slightly, though.
Hit me.
Why not just cram every single team rule into one giant prompt file? Wouldn't giving the AI more context always yield better, more accurate results?
It actually has the exact opposite effect, surprisingly.
Really?
Yeah. A massive bloated file completely overwhelms the agent's limited context window. It heavily dilutes the critical information. It becomes mathematically impossible for the AI to figure out which rules actually matter most for the immediate task at hand.
Right. Too much context just dilutes the most critical rules.
It is exactly like handing a new hire a 1,000-page manual on their very first day. They won't remember the truly important parts. You need a quick, scannable reference guide instead.
Okay, we are going to take a quick break, but when we come back, we'll look at what this all means for the actual humans running the floor.
Sounds good. the sponsor.
All right, we are back. So, we have encoded the hidden team knowledge cleanly.
We have.
We have automated our architectural guardrails with custom linters. The bumpers are firmly up.
Yep.
The entire system is humming autonomously. If you are managing an engineering team right now, this is where your workflow fundamentally changes.
Radically changes.
What does this actually mean for the human engineers running the floor?
It demands a complete reevaluation of our daily jobs. As the AI agents increasingly handle the raw code implementation, the human role completely changes.
We elevate from typists to systems designers.
That's exactly it. Let's revisit that incredible Coinbase example we mentioned at the start.
Yeah.
They didn't just casually slap AI onto their existing agile process.
No, they recognized the paradigm shift. They rebuilt their entire operational process from the ground up around Cursor. Teams now write product requirements specifically formatted so autonomous agents can easily read them.
Right. And they lean heavily into a feature called plan mode first.
Let's explain what that actually does mechanically before any code is written.
Sure. Plan mode forces the AI to stop and think systematically. Instead of immediately vomiting raw code, the agent reads the requirements and generates a comprehensive dependency graph.
So it outlines every single file it intends to modify.
Yep.
It proposes the specific architectural path it wants to take.
And the human engineer carefully reviews this logical plan.
They don't just blindly accept it.
No, they tweak the logic, identify edge cases, and only then approve the actual code generation.
And the resulting metrics from this workflow are just mind-blowing. Let's deliver those numbers again because they really reframe everything.
The total time from a raw idea to the first pull request dropped from 8 days to under 30 minutes.
Insane.
And the time from an idea all the way to a live production environment. That plummeted from 20 full days down to 1.8 days.
Oh, wow.
Imagine scaling to that level of speed, taking a 20-day product cycle down to under 2 days. That fundamentally changes reality.
The compound interest on that velocity is almost unfathomable.
It really is.
It shatters our traditional understanding of software delivery. But we have to emphasize it only works because of the senior engineers continuously managing those automated guardrails.
Exactly. And this brings us to the ultimate redefinition of seniority in this new era. It is a massive structural paradigm shift.
Because being a senior developer is no longer just about fixing a junior's architecture mistake in a manual pull request.
Right.
It is about creating a structural rule that stops every future coding agent from ever making that mistake again.
You solve the deeply complex problem once. Then you systematically automate the prevention.
Your hard-earned experience literally becomes part of the automated workflow.
Yeah.
You are coding your own expertise directly into the environment.
You are building the automated factory itself. You are
Yeah.
no longer just hammering the individual widgets on the assembly line.
But if senior devs are just building the factory guardrails now, how do junior developers ever learn the ropes?
That's a huge concern for a lot of people.
Don't they need to struggle through writing that raw code to truly understand the underlying systems?
Not necessarily.
Like-
They actually learn by interacting directly with the automated feedback loops.
Oh, interesting.
When a junior developer or their AI assistant makes a structural mistake, the system instantly catches it.
It doesn't wait for human review.
Right. It explains the failure and provides the fix in real time.
Fascinating. The system itself becomes an interactive mentor for the junior developers.
Yes, they get instant, perfectly accurate feedback on every single commit they make.
They do not have to wait 3 days for a senior engineer to review their code.
It is actually a vastly superior, psychologically safer learning environment.
Okay, let's pull all of these threads together for you.
Let's do it.
The great paradox of the coding agent era is truly fascinating. The more code the AI writes autonomously, the more critical your human-designed system rules become.
The robust automated tests, the intricate custom Lint rules, the continuous integration checks.
Exactly. Clear, hyper-concise documentation is more vital than ever before.
It really is the bedrock.
You solve a complex architectural problem once, you build a system that flawlessly remembers it forever.
Yeah.
The old legacy skills of system architecture and test-driven development are actually the master keys unlocking this new world.
It has been amazing exploring the mechanics of this with you. Thank you for joining us on this deep dive.
But before we sign off, I want to leave you with a thought. We are building these automated checks so the AI can safely update the code base today.
Right.
But what happens when the AI starts independently identifying massive workflow gaps.
Oh, boy.
What happens when it starts writing its own governing rules without asking for human permission first?
Oh.
Will our code bases eventually become completely self-governing entities? Something for you to chew on until next time.